Alloway presents Total Microcystins analysis by the ELISA method. Alloway is a full-service environmental laboratory specializing in analyses on drinking water, wastewater, and solid and hazardous waste. For more information about the services Alloway provides, please visit our website at www.alloway.com.
So I'm going to walk you through running Total Microcystins by EPA method 701.0. And we start by receiving our samples less than 4 degrees Celsius in a PETG plastic bottle. And we want to give them a really good shake. We're pouring the sample off into 2 40 ml vials, filling them up about halfway. And then pouring off into another cup to test the pH and chlorine. We make sure the bottles are really well shaken because microcystins like to float at the surface of the water, so that guarantees the most accurate result. And we do everything in duplicates, so when we get to the freeze-thaw process later, if any vials break, we still have a backup. And we're going to start with testing the pH. Swirl around in the sample. We're going to check and make sure that the chlorine's non-detect for each one. We're making sure to record all of the pH and chlorine results for each sample. Alrighty, and now we're going to start freeze-thawing our samples. So we have a 1,000 ml beaker here filled with 250 mils of ethanol, and we're going to add our vials to it. And then we add dry ice to accelerate the freezing. It typically takes about 5 minutes for the vials to get frozen completely solid. And after that, we'll thaw them in a water bath at 35 degrees Celsius. And we do this whole process 3 times to ensure that all the cells have been lysed. So we're going to check and make sure that each vial is completely frozen. And now we're going to place our vials in a water bath. Our water bath's at 35 degrees Celsius, and it should take about 15 minutes for these vials to thaw. Using a 0.45 glass microfiber filter, we're going to filter each sample, again shaking it up really well. And we're filtering about 2.5 mils into each vial. So once we have our samples filtered, we're going to get our microcystin test kit out. And this is the microplate that we use. And we're going to pull out just the rows and number of wells we need. So what we have here are our calibration standards. They come pre-made, ready for use, as well as our QC that we need, which is a lab blank, a second source, and a low-level check. And we're going to add 50 microliters of each standard into 2 different wells. Do the same thing with our samples. Now that we have all our standards and samples loaded, we're going to add the microcystin antibody solution. And we're going to add 50 microliters of this. Each of the wells is coated with a microcystin compatible protein, and what that means is when we add the sample in it, if there are any microcystins, they bind to that coating at the bottom of the well. Now there are a certain number of spots in each well that can be filled, and any that aren't filled by microcystins get filled by the antibody solution that we just added. And gently swirl the plate for 30 seconds. And now we leave the plate sit and incubate at room temperature for an hour and a half. So our plate is set for an hour and a half, and we're going to carefully pull off the tape. That's the tricky part. And now we're going to wash the plate out with a wash buffer 3 times. Smack it against the countertop to get all the water out. Just checking to make sure that absolutely all of the water is out of there. And then we're going to add an anti-sheep conjugate. And we add 100 microliters of this. So the conjugate that we just added will only bind to the antibody. So what's happening right now is this conjugate is attaching to all the antibodies that are attached to the bottom of the well. We're going to cover the samples back up. Swirl for another 30 seconds. And then we let the plate incubate at room temperature for 30 minutes. So our plate's been sitting for 30 minutes. We're going to carefully peel off the tape again. And repeat the same step. Dump it out and wash it with the wash buffer 3 times. Because everything that we need to read the samples is attached to the bottom on that specialized coating. Okay. Make sure we get all the water out again. Once you get all the water out of the wells, we're going to add the color reagent. We're going to add 100 microliters of this. once we add the color solution, that compound will bind to the anti-sheep conjugate, which is only bound to the antibody that we added in the bottom of the well plate. And that's going to turn it a dark blue or light blue depending on the amount of microcystins in it. Because this color solution only binds to the antibody and the enzyme conjugate, the darker the blue, the lower the microcystin concentration is. And then we cover it back up and swirl it for 30 seconds. And then we let it incubate at room temperature again for another 30 minutes. Okay, so our plate is incubated for 30 minutes. And the color is fully developed. So now we're going to add the stop solution, and it's going to change it to bright yellow. We're adding 50 microliters of the stop. It turns the blue immediately to yellow, and what this does is puts it in the visible light range for us to be able to read, and that is how we get the concentration for microcystins. And then we swirl that for 30 seconds. We're going to load the plate into the reader. And I've already loaded what our samples are. And then we just hit read plate. And this takes about 45 seconds once the lamp is warmed up. So I finished reading the plate, and now we're going to check the software to make sure that the curve worked and the QC worked and that everything on there is reportable.